Welcome to Module 9, Advanced Graphs.
We will be talking about the best ways to visualize distribution relationships, correlation relationships, and relationships with multiple units of measure. So let's start off with distribution relationships. So a distribution graph is going to display one or more sets of quantitative values across an entire range of values within the set or sets, generally from highest or from lowest to highest. And your histogram is your most common method of displaying distribution relationships. And basically, the histogram uses bars to represent the number of times a value occurs within a range of values. And you'll see histograms horizontally and vertically. Most of the time, you see them horizontally. So this is an example of a histogram. So this is examining salaries probably in a corporation, monthly salaries, and you can see by looking at the histogram that the majority of your salaries are going to occur between $800 and $1,100. You have a few outliers going upwards of $1,500, but not much. So this gives you a really accurate idea of where the majority of your salaries are within this organization. So the other way to visualize a distribution relationship is the use of a frequency polygon. And what that is, it uses a point instead of a bar to represent the number of times a value occurs within a range of values. The points are then connected by lines to visualize the shape of the distribution. So this is what a frequency polygon looks like. Now take note though that the polygon is always going to be closed at both ends of the area. So you can see around 35 on the x-axis and 175 on the x-axis. Those points are right on the x-axis, so the polygon is closed. This is what helps differentiate it from a line graph, which is a common misconception about frequency polygons. People think that they're line graphs or time series graphs, and they're not. So notice how the frequency polygon smooths out the shape of the distribution. So in this visual, you can see the brown area is the frequency polygon, and the dashed area is the histogram. So it kind of gives a smoother look to the distribution. One of the benefits of frequency polygons is that you can use them to visualize multiple distributions where you can't do that with a histogram. So this is an example of that. You can see from this visualization how cholesterol levels tend to increase as men age, because this is showing the difference between two age groups of men, 25 to 30 and 55 to 64. And this you could not do with a histogram because you can't lay one histogram atop of another. So that's the benefit of the frequency polygon. Before I move on, I want to point out a very nice usage of color here. Notice that not only are the frequency polygons different colors, so the one is red and the one is blue, but they've also matched the labels and also the title. They've identified the different groups based on the color. And that's really slick because now you really don't need a legend. So you're getting rid of some ink, unnecessary ink on your table, because you're using, you're identifying your categories in a different way. Okay, the other way to visualize distribution relationships is the use of a strip plot. And strip plots use points to display each value in a set. So unlike histograms and frequency polygons, they don't aggregate the values. So they also won't show the shape of the distribution. So here is what a strip plot looks like. So each point or each circle represents a value. And notice one of the difficulties with using strip plots is that your points will often overlap. So it's very difficult to tell the difference in points that are so very close together. And this is called mark eclipse. And there are a few ways around that with Tableau, and in the exercises, I'll show you how to do that. For strip plots that you have like really large data sets, you can add transparency. And this is kind of what I was talking about, how you can get around the mark eclipse. Compare the left strip plot to the right. Notice how they added some transparency to the marks in the right chart. So it makes it a little easier to tell the difference between the different marks in your chart. Also, by adding the transparency, you can see, you can get a little idea of the actual density in your strip plots. So that's an added benefit of using transparency. Now, for strip plots, you can also jitter your points. This jittering means you're adding just a small amount of noise to your plot so that the marks are separated from each other just a little bit. So instead of having those long lines, single lines in your strip plots, the points in your strip plots are just moved over just slightly. So this helps a little bit with being able to see the individual values, but unfortunately, the more jittering you add, the more confusing it is to a user to understand exactly what this chart represents. And the fourth way to visualize a distribution relationship is use of box and whisker plots. And these you use to visualize multiple sets of distributed values. And you've probably seen these before. The box represents the values between the first quartile and the third quartile. Your median is your second quartile. The area below the box are the values between or before the first quartile, and then from the box above, that is your third quartile to the fourth quartile, or to your max. Box and whisker charts tend to be a little confusing to users, especially when you get into something like this. This is a box and whisker plot that overlays strip plots. So when you get into complexity like this, sometimes it gets overwhelming to your user. And here's another example. This also incorporates the jittering that I talked about a few slides back. So this can be just really overwhelming for a user. Although you may want to choose to use a box and whisker plot, I would be very careful in regards to your user. Gauge their ability to interpret a box and whisker plots. And if anything, if you want to use that type of method, you can always simplify it by doing something like this. This is called a range plot. So it's basically a box plot, but no whiskers. So you still have your box that represents your values, and your line can represent, within the box can represent your median value. But it's a little easier for your users to understand. Okay, let's switch gears now to correlation relationships. So a correlation graph is going to display the relationship between two sets of quantitative values to see if there's a relationship between the paired set. So if there's a relationship, the graph is going to show the direction of the relationship. Is it positive or negative? And the strength of the relationship. Is it strong or is it weak? So your most common method to display correlation is a scatter plot. It's very much like a strip plot, but it has an X and a Y axis. And these are all scatter plot examples. But you can see the difference between a strong positive correlation and a strong negative correlation. And you can see the difference between a weak positive correlation and a weak negative correlation. And then you can also see what no correlation shows. So the thing to keep in mind is that line, that blue line in each of those graphs, that is a trend line. And you don't absolutely have to have a trend line, but it helps the user interpret the scatter plot. So in this one, you can see you have all your points in your scatter plot, but you also have that light gray trend line. And that's going to help the user understand that there is a specific direction to the relationship. This would represent a positive relationship. And then how closely the points gather around the trend line show how strong or weak the relationship actually is. And I would say this is probably a fairly weak relationship. Okay, the table lens. This is another way to visualize correlation relationships. It uses bars and not points, and it's not used as frequently as the scatter plot. Let me show you what it looks like. So basically, you have two bar charts. Your first bar chart, the one on the left, is going to be your independent variable. The one that you want to look at to see, okay, when that value changes, how does it affect the values on the right chart? So that's how table lenses work. And table lenses can be confusing for users if they never used them before. So again, you need to make sure that you're very cued into your user and what works best for them to understand the data. One of the benefits about table lenses is that they're really good to use if you have multiple sets of values, which you can't do with a scatter plot. So this one compares fertility rate to male and female life expectancy at birth. So this is something that you couldn't do with a scatter plot, but you can do with the table lens. So looking at the left, the chart on the left, the fertility rate, as that fertility rate changes, how does it affect the life expectancy for males and the life expectancy for females? Okay, now we're going to talk a little bit about how to visualize multiple units of measure. So you can use a single graph or multiple graphs if you need to visualize relationships with multiple users of measure. But you have to be really careful when you're using single graphs. You can use single graphs if you have the same type of measure. So if you have all currency, if you have all numbers, then obviously it's okay to use a single graph. So you can use lines like this, or you can use bars. So you have different units, you have the same type of measure, but you have different sets of values. So for a single graph, you can also do something called a dual axis. You can use a dual axis if you have different units of measure. So let's say you have currency and number. However, if you use the same mark type, so if you use bars for both and use lines for both, it can be confusing to your user. And let me show you a little example of that. So this is dual axis. So you can see why it's called dual axis. You have two y-axes. The one on the left, in this case, represents a sum or profit, and that's a number, a currency value. Your axis on the right represents order quantity, so that's a number. So it can be confusing for the user because they think when they see these, they see this as a line graph, and they think that that the units of measure are the same. So if your user isn't really savvy and understand that those two units of measure are different, it can be confusing. So to avoid that confusion, you can do something called a Pareto chart. And this is what a Pareto chart looks like. Basically, it's the same thing, except you're using one type of mark to represent your values on your first y-axis, and another type of mark to represent the values on your second y-axis. So in this case, the first y-axis is represented by bars, and your second y-axis is represented by the line. So that makes it a little bit easier for your user to understand that you're looking at two different units of measure. Multiple graphs. Now, these are frequently called small multiples, sometimes trellis charts, but they will display relationships between multiple quantitative values or categorical items. And you can use bars or lines for this, but you need to make sure that your mark type is consistent across all of your charts. So here's an example of a small multiple. And this is using lines. And notice how everything looks basically the same. The titles are in the same font, the same color. Your lines, same color. Notice that the label on each line graph is the exact same one. It's the final point in your line. The x-axis and the y-axis are all the same. So it makes it easier for the user to understand what's going on here. This is the same thing, except using bars. Not the same graph as the previous one, but it's the same example of small multiples, but using bars. And you can even use maps for this. Okay, so when you're going to use small multiples, let's talk about the best way to do that. First of all, you have to make sure that all your charts fit on one viewing screen. So no scrolling. If you're printing it off, you want it on one page because you don't want to break your charts up. Also, make sure you're consistent in your design in each chart, like I talked about a few slides back, and eliminate any redundant labels. So let's see if there's a good example here. Like this one, you wouldn't want to have a y-axis on each of these charts. That would put too much ink, unnecessary ink into your chart. So what this author has done is just used the y-axis on the first chart of each row of charts to represent all of them. So that helps make it a little bit cleaner and easier to read. Make sure you order your categorical items consistently. Limit the use of rules and grids. With some charts, you do want to have rules and grids on them, but with small multiples, you pretty much want to eliminate them as much as possible because it just adds too much clutter to the sheet. And also when you're ordering or organizing your multiples, organize them in a way that you think your user would find it most helpful. So for example, in this one, your user may prefer to have the age categorical items across the top and the income items across the side. Basically, you just have to ask your user what their preference is. So that is it. Now go on to the practice exercise. I will be showing how to do a few of these techniques in the practice exercise, and then you will be ready to start your graded exercise for the module. Thanks.